So today's lesson is about circles. But before we can talk about circles, we're going to talk about the distance formula. So the distance formula, if you didn't know, is an example of the Pythagorean theorem. So the distance formula is distance, so d equals the square root of x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. And all of that is underneath the radical. Now, some things to keep in mind. One, you can't get rid, even though these are both squared, you can't cancel them with the square root because of this plus sign right there. And another is you could switch the order that you do your differences underneath the radical, and you could do x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, right? And you get a little leeway with distance formula because of the squaring. You can actually mess up a little bit and swap the order. As long as x is x's, y is y's, and you're good. So, how is this the Pythagorean theorem, you might be asking? So over here, I've got a little picture. I have my 2 points, x sub 1, y sub 1, x sub 2, y sub 2. We're looking for this distance here in between them. Oh, and when we say distance between them, we're talking about the shortest distance, right? A straight line between them, so not some roundabout way. So pretend I've drawn a line parallel to the x-axis and parallel to the y-axis. So we have our right angle there. So this distance here, right, along the x-axis is the difference between my two x values. So this length here is x sub 2 minus x sub 1. And up here, there's a vertical distance, right? Here's the value here is y sub 2. The value here is y sub 1. So that is y sub 1 minus y sub 2. Right? And the Pythagorean theorem says, right, if you square the lengths of the sides of a triangle, right, and add them, you get the square of the hypotenuse. So x sub 2 minus x sub 1 squared, a squared, plus y sub 2 minus y sub 1 squared. So a squared plus b squared equals c squared. So in this case, d squared. And then if we just square root everything, we will get just what I have on the left, d equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, if you're not comfortable or you've gotten in trouble mathematically in the past by just canceling those, go ahead and swap in some numbers for the x's and y's and see that you get different numbers if you just drop the square root in the square versus, right, not. Okay? The not is the correct way to do it. Okay, so find the distance between the points A and B if A has the coordinates 4, -3, and B has the coordinates 0, -8. So if you are distractible or you have other things going on and you're not able to finish, a strategy is to go ahead and label the coordinates that you have so that if you like get pulled away right in the middle of it and you come back, you know who's playing what role. So x1, y1, x2, y2, whichever, right, however you're going to do it, it's going to be fine. So d equals square root. Sometimes, right, if I'm particularly I don't know, like have my head in the game, I'll try to subtract so that I get rid of as many negative signs as I can. I don't really care this time, so I'll just start from the 4 minus 0 squared, and then -3 minus -8, right? I'm putting it in the -8 in parentheses so that I can deal with my negative signs. I'll close the parenthesis for the subtraction, square it. So we'll do the math inside. So 4 minus 0 is 4 squared, so 16. Second one, I'll have to think a little bit harder. So I have -3 minus -8, so that'll be plus a +8. That'll give me 5 squared. Oh, that's 25. Okay. So I have D equals the square root of 41. Now, depending on how you're doing your homework, what your particular instructor prefers, your answer might look like this. This is what we call an exact answer. Okay. It has all of the information in it. There was no rounding that took place. Now, if you want an approximate answer, then we would do the square root of 41, and you should sort of ballpark it so you kind of know, right? Something a little bit bigger than 6, and there it is. So D, and if we're going to approximate, we're going to use the squiggly equal sign. So is approximately 6.4, and then wherever you are asked to round. That's a pretty good round, so I would say a rounded answer would be 6.4. Okay, so let's do it a different way. And really, to be honest, at this point, what we're doing is we're just flexing our algebra skills. Okay, so we haven't really got into any trigonometry yet. We're just flexing those algebra skills, getting ourselves warmed up. So find all x's such that the distance between A and B is 5, where x has the point x1, A has the point x1 and B has the point coordinates 9, -3. So here we go. We're just going to use the distance formula and plug things in where they go. So the 5 goes in for the D. So 5 equals square root of x minus 9 squared plus 1 minus -3 squared. Okay. So now here's the unknown, right? Here's my x inside. So I want to get rid of the square root. Okay. So in one step, I'm going to go ahead and tidy up the second set of parentheses under, and I'm going to get rid of the square root by squaring both sides. So I'm going to square both sides of my equation, which is a legal thing to do if I do it to both sides of the equation. 5 squared is 25. Now, because I'm squaring the entire square root, this is how we can cancel them. So now I have x minus 9 squared plus, let's see, 1 minus -3, 1 plus 3, so that'll be 4 squared, so that'll be a 16. Okay. Now you could go ahead and square out your x minus 9. Be careful if you do. I'm going to leave it and use the square root properties, so I will subtract 16 from both sides. That's going to give me 9 equals x minus 9 squared, square root both sides. So I'm going to get the square root of 9 equals, I'll show you what that looks like. So here's my square root, the square root and the square can cancel there. When we do the square root property, we include the plus or minus with one of the sides. So what am I going to get? Plus or minus 3 equals x minus 9. Add the 9 to both sides. 9 plus or minus 3 are the x values. So what is that? 9 plus 3 is 12, and 9 minus 3 is 6. Okay. So those are the x's, so that the distance between the point 9, -3, do a little quick graph here. So 9, -3 is about here. Okay. And then I know that my y value is 1, so I'm someplace along this line. Okay. And I want the distance between the x value and that point to be 5. So it could happen either over here at the point 6,1 or over here kind of off my page at the point 12,1. All right. So circle definition from your maybe a high school geometry class. Right? It is the set of all points equidistant, distant from a fixed point. So remember, equa means same. And so same distance from a fixed point. So we just talked about the distance formula. So how can we use that to find the equation of this circle? Okay. So we'll let the set of all points be xy. And that fixed point is going to be known by the coordinates hk. So using the distance formula, distance equals, right, because we want it to be constant. This is my equidistance, this d. And so now I need the distance between, right, the points xy and that fixed point hk. So x minus h squared plus y minus k squared. So distance equals x minus h square root of x minus h squared plus y minus k squared. Square both sides so that I get d squared equals x minus h squared plus y minus k squared. So I squared both sides, got rid of the square root on the right, kept the squares on the inside because I haven't dealt with them yet. And this is the equation of a circle, or a formula to write down, right, the relationship of a circle. So what that looks like, right, so hk is my fixed point, and then all of those points on the exterior of the circle, right, can be xy. And this is our common distance. And right, really, we're not going to write it as a d. We'll write it as exactly r. So this is how we're going to use it. So x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the exactly radius. I know, I hear a bunch of you hollering out. So the thing you're thinking about is the circumference. That's the distance all the way around it. Don't worry, we're going to talk about that later this quarter. So circumference is 2 pi r. And then the other formula for circles is area. Area equals pi r squared. We don't need those today, but in case they were tickling in the back of your head, that's what you were coming up with. Okay, so let's practice writing equations of circles. Okay, so for the circle given by x plus 2 squared plus y minus 6 squared equals 81, what is the center? Okay. So you can look back at the previous page, right? Figure out who's playing what role. Okay. So the x part of the circle, of the center, notice I have x plus 2, but the formula that you had was x minus h. So what would h be so that I can get this plus on the inside? Exactly, we have to change its sign. So x minus negative 2 is the same thing as x plus 2. Okay, so the h is the x part of the center. So negative 2 comma 6, because it's y minus k, the minus is there, so we're good there. And then the radius is the square root of 81, which is 9. Okay. So again, flexing some of those algebra skills, can we find, for this circle, can we find the x and y intercepts? So remember the x-intercept is the point or points where the graph intersects the x-axis. And the x-axis is the horizontal one. Okay. And the thing that's true there is that we know that the y value is 0. Okay. So if we're looking for the x-intercept, we find it by plugging in y equals 0 and solving for x. So here we go. So let's find the x-intercepts first. So we're going to set y equal to 0. So set y equal to 0 and solve for x. So x plus 2 squared plus 0 minus 6 squared equals 81. I'm not going to FOIL that out, right? I'm still going, because I have this x plus 2 squared and everything else is a number, I don't have another variable over there, I know I can do the square root property. Okay? And that's going to be easier than anything else for solving these quadratic equations, these equations with squares in them, okay? So x plus 2 squared plus 36 equals 81. Subtract the 36 from both sides. So x plus 2 squared equals, I'm not going to trust my subtraction, 45. Square root both sides. So x plus 2, because the square root and the square go away. Square root property requires the plus or minus square root 45. Okay. And now I'm going to do two things in my next step. I'm going to subtract the 2 from both sides, and I'm going to simplify the radical. I'm not going to grab my calculator, right? I don't want the decimal version, but I'm going to take that 9, that's a factor of 45, right? And is a perfect square, and I'm going to go ahead and bring that out to the front. So I'll have x equals negative 2 plus or minus 3 square root of 5. Okay, the negative 2 when I subtracted 2 can't combine with anything else because this has a square root 5 and that doesn't. The 3 square roots of 5 are because that becomes the square root of 9 times the square root of 5. Square root of 9 is 3. Square root of 5 tags along. So there are two values where the circle crosses the x-axis. Okay. So sometimes I will, right, depending on how it's asked for, if I want the coordinates of the whole point, so the x part is negative 2 plus or minus 3 square root 5, it's a little cheaty, comma 0. So put the 0 in so it does look like the ordered pair that it is. Okay, so there are the x-intercepts. Do you want to pause and try the y-intercepts first before I jump in there? Okay, if not, here we go. So y-intercepts, right, same idea, except it's the x that gets replaced with a 0. So 0 plus 2 squared plus y minus 6 squared equals 81. 4 plus y minus 6 squared equals 81. Sorry, y minus 6, I caught that. Y minus 6 quantity squared equals 77. So y minus square root both sides, y minus 6 equals plus or minus radical 77. So y equals 6 plus or minus square root 77. So the coordinates 0, comma, 0 for the x, 6 plus or minus square root 77. So this circle that we started with did have two x-intercepts and two y-intercepts. You can imagine, and you could draw a circle that had no intercepts, right? So it would have been, this is not the circle, this is just a kind of a counter example almost, that not all circles have to have intercepts. Okay. So this circle here does not have an x-intercept or a y-intercept. If we would have gone through this process we just did for the circle I just drew over here in green, what would have happened is we would have come up with imaginary numbers when we tried to do the square root property. Okay, so you're going to get a clue that's like, oh, this one doesn't have them. That clue is going to be a square root of a negative number. Okay, so write the equation of a circle with a center of 2, negative 3, and a radius of 10. Oh, well, that's not too bad. So what do I have? Oh, that's supposed to be an x. X minus 2 squared plus y minus negative 3 squared equals 10 squared. So I'll just write it a little bit neater here. So x minus 2 squared, let's say minus negative 3, y plus 3 squared equals 100. All right, now find all points where the circle above, so the one we just wrote, intersects the line y equals 2x minus 1. And again, you can imagine, right, here's this circle up here. We could draw many lines that do not intersect it at all. But there are also many lines that do, and we don't know what we're going to have here. Okay. So if you come up again with that square root of a negative, it probably means it doesn't intersect. It probably means you should go back and check your algebra and make sure you didn't drop a negative sign somewhere. But if it's all good, then that means they just don't intersect, which is a fine thing that happens too. Okay, so here we go. How would we find the points, if they exist, where these two things intersect, where this circle and this line intersect? Well, we're going to do a substitution. So this y is going to get replaced, the y in the circle is going to get replaced with a 2x minus 1. And what that's going to leave us with is an equation that only has one letter, x, this time in it. So 2x minus 1, so that y is just getting replaced. And then plus 3 quantity squared equals 100. Okay, so what are we going to get there? Oh, okay, I think we actually have to do the foiling out here. So this algebra might get a little bit messy. I might need a little bit more paper, but here we go. We'll just keep moving through. So I'm going to tidy up inside the second set of parentheses. I'll try not to go too many steps in one. So 2x plus 2 squared equals 100. I know it's tempting. Don't do it. Right? Squared, squared, squared. You want to just get rid of all those squares, but we can't. And you all see with the thing that's keeping us from doing it, right? It's that plus right there. We can't take the square root across this plus here. So instead, I'm going to have to expand both of those binomials. So we'll get x squared minus 4x plus 4. If you didn't get that, go ahead and write out the x minus 2 times x minus 2 in FOIL. Doing the next one, plus 4x squared plus 8x, that's right, plus 4, okay, equals 100. Combine like terms. 5x squared, I'm going to cross off as I go so I don't lose anybody, plus 4x plus 8 equals 100. Okay, and then it's quadratic, which means, and I can't do the square root property because I have this 4x here, this linear x term. So that means I need a 0, so I'm going to subtract 100 from both sides. So 5x squared plus 4x minus 92 equals 100. Oh, for goodness sakes. So we could try to factor, but I'm not because I've got a sledgehammer tool that always works on quadratic equations. And that tells me the answers are, y'all know what I'm talking about, right? Yeah, quadratic formula. So x equals negative 4 plus or minus square root of 4 squared minus 4 times 5 times negative 92 all over 2 times 5. So x equals negative 4 plus or minus square root all over 10. Okay, let's figure out what that radical is. I'm going to grab my calculator because, oh, you can see my skylight there. There we go. What do we have? 4 squared, so 16. And then notice here I have the negative 4 from the formula, from the quadratic formula, right? Negative 4ab, or sorry, negative 4ac. Negative 4 times the negative 92 is going to be a plus. So I'm just going to do the plus right here. So plus 4 times 5 times 92. Oh, goodness sakes, that's a big one. 1856. Okay, now because I'm kind of going long on our video here, I'm going to go ahead and stop there. I'm sure that that has a nicer value. So those are the x values. These are the x coordinates of the points of intersection. If we wanted to find their y partners, we would take them individually, right? The plus is one of them, the minus is the other. We would take those and plug them into the equation of the line to find the other two values. Okay, so that is what we need to know about circles for now.